in which it says that it's recording video but not audio, but I don't want that. Okay, perfect. So a final set of identities. Half angle identities. Half angle identities. Okay. Those half angle identities mean basically sine alpha over 2. And you can say, but you already showed us an example. Yes, based on the double angle, yes. But this is, in addition to that, we have special, you can say, but you already have this here. Yeah, but we also have something else that is very important. So we want to look at sine alpha over 2, cosine alpha over 2, and tangent alpha over 2. This is our last target. I promise for now these are the last identities. Okay, so one of them, which is this, one of the important formulas for tangent alpha over 2 are those two that we started with last time. Remember sine, 1 plus cosine, and 1 minus cosine. So this is that important identity that we started with, and I still have it here, which is this. It was the first thing we did last time. And I said it's a very important, and you'll see why. And this is it. However, this is not the only formula for tangent alpha over 2. The other formula will come from this over this in a minute. So let's discuss these two next. Now remember that we had cosine twice alpha as being cosine squared alpha minus sine squared alpha. Also, the second option, 1 minus 2 sine squared alpha, or 2 cosine squared alpha minus 1. So this is just what we looked at a minute ago, maybe 5. Okay. So I'm going to use that little trick that I showed you a minute ago. So cosine alpha, not 2, equals 1 minus 2 sine squared alpha over 2. So if this is alpha, this must be twice alpha. If this is alpha over 2, this will be alpha. And I'm also going to use the other one. So cosine alpha equals 2 cosine squared alpha over 2 minus 1. From these two identities, we will solve for sine alpha over 2. Why? To get the identity for sine alpha over 2. And then I'm going to solve for cosine alpha over 2. Why? To get the identity for cosine alpha over 2. Where did this come from again? From cosine twice alpha. What did I do? I wrote the 3 formulas, the 3 identities. I'm only interested in this one and this one, not in this one. Then I used a little trick. This is true for any angle, as long as this is double of this, double of this, double of this, double of this. And from here, we will solve for sine, first for sine squared, and then for sine, and the same thing here. Good. So 2 sine squared alpha over 2 equals 1 minus cosine alpha. This is a tremendously important formula in Calc 2. So sine squared alpha over 2 is 1 minus cosine alpha over 2. If I want to solve for sine, I have to take the square root. Sine alpha over 2 is plus or minus the square root of 1 minus cosine alpha over 2. Very, very important formula. The same formula is for cosine alpha over 2, but with plus here. And these are the last identities, I promise. So that's 13. Okay, so cosine alpha over 2 equals plus or minus the square root, identical, but 1 plus cosine alpha over 2. And what will be the last formula for tangent alpha over 2? Of course, this over this. Plus or minus the square root of 1 plus cosine, no, I meant to write minus, of course, over 1 plus cosine alpha. I meant to write minus at the top. It's this over this. Okay, as you see, one comes from the other. Okay, so now let's see how we use these. And of course, you can write this formula as one single square root. So plus or minus the square root 1 minus cosine alpha 1 plus cosine alpha. So let's see what we want to work with. So let's choose from the sine alpha over 2, cosine alpha over 2, tangent alpha over 2. Which one would you like to work on? Anyone, please?
Can we do A?
Oh, that's sine twice alpha. We can, but we want to focus on half the angle. So
Okay,
we worked on cosine twice alpha, and we worked on tangent twice alpha or theta. But
okay.
we want to work on any of the half angle, theta over
C.
2. C, perfect. So we want to find sine theta over 2. Perfect. We are told that theta is an angle between 0 and 2 pi. Find the exact value of such and such, and we have the same information. So I have to go back and just copy what we had. What did we have? We had sine theta -1 over the square root of 5. We had cosine theta -2 over the square root of 5. Perfect. Okay. So this was from our previous calculations. Good. So sine theta over 2 is plus or minus the square root of 1 minus cosine theta divided by 2. Now, we have to wonder what's going on here. Let me see what else we had. We also had that theta was, where was theta? Yes, theta was in the third quadrant. So theta is in the third quadrant, which means from pi to 3 pi over 2. Now the question is, what do I pick? Do I pick positive or negative? Not a problem. First of all, I will divide this inequality by 2. Why? Because I would like to know where pi over 2 is. Which quadrant? Not where pi is. I know pi. Pi is between, theta is between pi and 3 pi over 2, but I want to know theta over 2, where it lands. Okay, so I'll divide both sides by 2. So I have pi over 2 less than or equal to theta over 2 less than or equal to 3 pi over 4. But which quadrant is this? Can anyone tell us which quadrant is between pi over 2 and 3 pi over 4? And then I will write that pi over 2 is in which quadrant?
The second.
Yes. Because it is in the second, I can only use positive, because sine in the second quadrant is positive. So therefore, I can continue. 1 minus cosine theta was determined, but minus and minus plus 2 over the square root of 5, everything divided by 2. Yes, it needs a little bit of simplification, but first I had to use the formula. Sine theta over 2, which we wrote up there. Sine theta over 2 is plus or minus the square root of 1 minus cosine theta over 2. Remember, theta over 2, theta. Then I had to write this inequality, compound inequality, stating, okay, where is theta? Well, we determined that. The theta was in the third quadrant, between pi and 3 pi over 2. I had to divide both sides by, all three sides by 2, because I want to determine where this is, so that I know whether to choose plus or minus. So I realized that this is in the second quadrant. Fine. Then sine must be positive in the second quadrant. So I replaced cosine by this with minus minus. So then finally I have some form here. Not a nice form, but I have the square root of this 2 plus the square root of 5 over 2 the square root of 5. And this is good enough. So that's how we use the half angle identities. So I know let me look at my phone, only my phone, so it says 3 minutes. So I don't know if I should start anything in 3 minutes or not. You see here the formula that we discussed. Tangent alpha over 2, sine alpha over 1 plus cosine alpha, 1 minus cosine alpha over. Okay. And the same thing, but without the plus or minus and the square root, which is the same thing. We're going to work on these formulas. And we're going to look at some identities, and we're going to solve some equations. And that will be the end of identities. And we'll be moving to applications. And I had a lot here in the background. Yes. So we're going to continue with 7.1 on Wednesday, but not before we work on more problems